This video is part 2 of our angle relationships, and this is looking at angle relationships when you're dealing with a parallel line or a set of parallel lines, and these parallel lines must be cut or intersected by a transversal. So we're going to go ahead and take a look at what does that mean, what does that look like, and talk about some of the relationships that come from that. So we're going to start with the definition for parallel lines, and parallel lines are two lines that never intersect. So we're going to go ahead and fill that in. So again, two lines that never intersect. The symbol that almost looks like two capital I's side by side is used to indicate parallel lines. So an example of parallel lines, if we take a look down at this picture, if we labeled this line, line L, and line M, that tells me that line L is parallel to line M. Let's say then that this diagonal line right here, that diagonal line, we're going to name line X, and that would be considered our transversal. So our transversal in this case would be line X. A transversal is a line, a ray, and these should all be review, or segment, so a line segment, that intersects or crosses two lines, rays, or segments. When a transversal intersects two parallel lines, angle relationships form. So any angle relationship that we talk about in this video is going to be because these two parallel lines are cut by our transversal line of X. So let's go ahead and take a look at our different angle relationships. So if we take a look at the first three, our first example is going to be alternate interior angles. So if we break that apart, alternate means every other, interior means inside, and then angles are obviously what we've been talking about, so made by two lines. The idea of interior, and you may want to write this down, your interior is going to be the space inside, or the space between the parallel lines. So again, you want to write that down. So interior would be the space between the parallel lines. If we go back up to the definition of alternate interior angles are angles that are on the inside of the parallel lines and on opposite sides of the transversal. So for example, if we take a look, angle 3 is an interior angle because it falls in between our parallel lines. So angle 3 would have the same measure as angle 6. Notice that angle 3 is on the same or in the same location as angle 6, but on opposite sides of the transversal. Okay, so angle 3 and angle 6 would represent alternate interior angles. Alternate exterior angles would be angles that are on the outside of the parallel lines and on opposite sides of the transversal. So if we take a look, for example, at angle 2 is on the outside of the parallel lines, angle 2 would match up with angle 7 because angle 2 is on the right side of the transversal and angle 7 is on the left. So alternate exterior angles. So angle 2 and angle 7 would be an example of alternate exterior angles. The final example that we're going to take a look at on this slide are corresponding angles. Corresponding angles are angles in matching corners. Okay, so matching corners. So for example, if we take a look at angle 1 matches up with angle 5. So they're basically in the exact same spot, just on the different parallel lines. So angle 1 and angle 5 would be considered corresponding angles. Once we know that we have these relationships, that tells us that the angles that make up those relationships are equal. Okay, so for example, angle 3 and 6 are equivalent or are congruent or equal to one another. Angle 2 and 7 are also equal or congruent to one another, and angles 1 and 5 are equivalent or congruent to one another. The last 4 types of angle relationships that are formed when a transversal cuts through a set of parallel lines include same side interior angles, same side exterior angles, vertical angles, which we've already talked about, and the idea of a linear pair, which we've touched on a little bit. So let's go ahead and take a look first at our same side interior angles. These are the angles that are on the inside of the parallel lines, and they have to be on the same side of the transversal. Hence the word same side interior angles. These angles are supplementary. And if you think back to what supplementary means, that means that they are equal to 180 degrees. If we take a look, an example of our same side interior angles would be, if we look at angle 3, we need to think about, okay, here's an acute angle. Angle 5 would be the partner to make up the same side interior angles. So angle 3 and angle 5 would be an example of same side interior angles. Also, if we take a look at another example for same side interior angles, we would have angle 4, because again it's on the inside of the parallel lines, and we'd have angle 6. So angle 3 and 5 would be partners, and angle 4 and angle 6 would be partners. Again, these would be equivalent or congruent to one another. Same side exterior angles, so the exterior part would be the outside, which I forgot to say earlier. So if we look, exterior just means that it would be the space outside the parallel lines. So again, you want to write that down. So exterior means the space outside the parallel lines. So if we take a look at same side exterior angles, would be angles on the outside of the parallel lines and on the same side of the transversal. Again, these angles are supplementary, meaning that they equal 180 degrees. An example of same side exterior angles would be looking at angle 1, and angle 1 would match up with angle 7, and those would be considered same side exterior angles, okay? And again, those would be equal to 180 degrees. An example, like I said, of these would be angle 1 and angle 7. And again, if we take a look at angle 2 and angle 8. And again, those would be equal to 180 degrees. The last two examples include our vertical angles, so those are angles that are opposite each other when two lines cross. So if we take a look, angle 3 and angle 2 are opposite of one another. So those would be vertical angles, so angle 2 and angle 3. And remember that with vertical angles, they are equal, or we are using that word congruent to one another. Another set of vertical angles would be angle 7 and angle 6. Another set would be angle 5 and angle 8. So again, any set of angles that are opposite of one another and have the same measurement would obviously be equivalent or congruent. The last example of our angle relationships would be a linear pair. So a linear pair are two adjacent, so side-by-side angles that form a straight line. So for example, angle 1 and angle 2 would be considered a linear pair because they form a straight line, which is equal to 180 degrees, or a line, right? So a straight line. If we look down here, we could say that angle 7 and angle 5 also are linear because angle 7 and angle 5, when we trace that straight line, here's angle 5, here's angle 7, and they both make that straight line or straight angle. So right now you're going to go ahead and practice to utilize or use the vocabulary and the examples that we highlighted in the beginning part of this video, and you're going to complete numbers 1 and 2 on the next page in your packet. So go ahead and check your answers for number 1. So you should have used the fact that this is line L, this is line M, they are parallel, and they are cut by this transversal. So if you haven't already done so, go ahead and do number 2. So you're identifying what kind of relationship there is for each pair of angles. And go ahead and take a look at the answers for numbers 1 through 10 under number 2. Check those answers as well. So we're going to do some more practice obviously in class, but hopefully this is a good preview for our next set of angle relationships when we're looking at two parallel lines that are intersected or cut by a transversal.